Today we're going to be solving cubic equations and inequalities. All right, so here's your state standards and your success criteria. Today you need to be able to explain how solutions of equations and zeros of functions are related. You need to be able to solve a cubic equation. You need to be able to write a polynomial function when given information about its zeros. And you need to be able to solve cubic inequalities. The vocabulary for this unit is repeated solutions. All right, so a repeated solution is when a factor such as x minus 3 appears more than once. This creates a repeated solution of x equals 3. And you'll see that affects the graph, and when we look at examples, we'll look at how that does affect the graph when you have repeated zeros. A cubic inequality in one variable x can be written in one of the following forms, where a, b, c, and d are real numbers and a is not 0. Remember, the leading coefficient, the highest exponent, is your degree. The degree determines what kind of function it is. Well, it's not cubic if a is 0. So if this would be 0, that whole term would be 0, and it would just be a quadratic or whatever your highest degree is. So in order to be cubic, it has to have an a not equal to 0. And a, b, c, and d are real numbers. Two theorems that you need to be aware of. We will talk about these as we go. But the rational root theorem and the irrational conjugate theorem are two things that we will talk about today as well in solving cubic equations and inequalities. All right, example 1. Solving a cubic equation by factoring. So it says solve 2x cubed minus 12x squared plus 18x equals 0. Hopefully you recognize that these are all even numbers, which means they is a factor of 2. There's a factor of 2 that can be factored out, and they all have a variable of x. So our greatest common factor is going to be 2x. So the first thing I'm going to do is factor out a 2x. That leaves me with x squared minus 6x plus 9. And this is an equation, so even though I factored out my greatest common factor, I still have this equal to 0. Now, this is a trinomial that can be factored further, more than likely. It looks like it can be factored further, so let's go ahead and see if we can factor this. We have x squared, so we know we're going to have x times x. What multiplies to give us 9 and adds to give us negative 3? Well, that would be negative 3 and negative 3. So you can double check. X times x is x squared. Minus 3x and minus 3x give me negative 6x in the middle. Negative 3 times negative 3 is positive 9. So you can use the distributive property to check to see if you factored it correctly. All right, so now we do have a double 0, so we can write this as 2x times x minus 3 squared equals 0. And that's the same thing. It's just kind of condensed, showing that this factor shows up twice. All right, so to solve, we have to set each factor equal to 0 using the zero product property. So I'm going to solve by setting 2x equal to 0, divide by 2. So 0 divided by 2 is 0, so that's one solution. And then I'm going to have x minus 3 equals 0. Add 3 to both sides, and x equals 3. Now, x equals 3 is a repeated solution. So if you graph this, you'll see that the graph, it comes down and touches at the x-axis, but it does not cross. So let's kind of look at what that looks like. All right. Here we go. All right, so I'm going to just graph my function here. You can either graph it in standard form or you could graph it in factored form if you want to. But we can just quickly graph 2x cubed minus 12x squared plus 18x. I'm going to hit graph. Okay, this is in standard form here. This is what we started with. Let's hit zoom 6. Zoom standard takes me back to a normal 10 by 10 window. See if I can see the function from here. There it is. All right, so you can see it crosses at 0. That is one solution. Okay, x equals 0. And then it crosses at 3, but it doesn't cross at 3. It comes down and it touches and it goes back up. The reason it does that is because of this repeated 0. So anytime you have an even or a factor raised to an even power, it's going to come down and it's going to touch the x-axis at that 0. So that is a solution, and that shows that it is a solution twice. So cubic function is going to have 3 solutions, 0, 3, and 3 is repeated. So it's 3 2 times. So we kind of summarize that in saying that when a factor is raised to an odd power, like this one is raised to the first power, when it's raised to an odd power, the graph is going to cross at the x-axis. So you can see here it crosses. When it's to a power of 1, it would also be the same if it's a power of 3 or any odd power, it crosses the x-axis. If a factor is raised to an even power, then the graph touches the x-axis, but it does not cross. So that just kind of summarizes what that kind of means when you have repeated zeros. Example 2, finding zeros of a cubic function. Find the zeros of f of x equals 2x cubed plus 16x squared plus 32x. Then sketch a graph of the function. All right, so this one is similar to example 1 in the fact that all of these numbers are even and they all have the same variable in common. So the first thing I'm going to do is factor out my greatest common factor again. I'm going to pull out 2x. I'm left with x squared. 2 goes into 16 8 times. I have x left over. 2 goes into 32 16 times. And the x is already factored out, so there's no x in the last term. All right, so that can be set equal to 0. In place of f of x, we're just plugging in 0 so that we can solve. And then we're going to say 2x times what? Can this be factored again? So we got x squared, so x times x. What multiplies to give us 16 and adds to give us 8. So that will be 4 and 4. Both of those are positive because we have 2 positive signs here. And again, we have a multiple 0. So we have x plus 4 squared times 2x equals 0. So this would be our function in factored form. So this is standard form. This would be factored form. And now we can tell a little bit about the graph. So it says sketch a graph. All right, so as you've seen, you can just type this in your calculator and you can have a actual to scale graph if you want. But there's some things you should be able to recognize just by looking at the function. First of all, the end behavior. Because this is positive and because this is a cubic function, so we know a cubic function is one of 2 ways. It's either going to be like this or it's going to be like this. So if it's positive, if the leading coefficient is positive, it's going to look like this one. If the leading coefficient is negative, it has the same shape, but it's kind of backwards. The end behavior is backwards. So we know that 2x cubed, that is positive. So we can say that it's going to have this general in behavior here. All right, so what else do we know? We also know that it's going to cross the x-axis at 0. So here it's going to cross at 0, and then it's going to come down and touch at -4, because if I do x plus 4 equals 0, subtract 4 from both sides, that's going to be -4. So if we want to sketch this graph, let's draw a little graph here. We know it's going to cross here. We also know it's going to touch at -4. So let's say this is -4. And we're just going to kind of come up and have something like this. Okay, so again, we know it's this general shape from the end behavior. And we know based on the zeros or the factors that it's going to look something like this. Now, if you want to see the exact graph or be more specific, again, all you have to do is type it into your calculator to see that. So let's do that quickly. Okay. So it did say to sketch a graph. Sketch just means a rough draft or a rough estimate of where those points are going to be. So 2x cubed plus 16x squared plus 32x. And then if I hit graph, we want to see that the end behavior is correct. We also see that it touches at -4 and it crosses at 0.